Alrighty, welcome back. So we're on episode 12. You'll be delighted to know that the subscribers have just passed 2,000, so that's fantastic. It's small numbers in relation to other channels, but again, I don't really mind. The information is going to be here for forever, hopefully, so it can be referred back to in time. I'm not, as I said before, I'm not after huge traffic. It's a niche market. But it is exciting, that it's just gained that much traction so quick. So in this episode, which is 12, I will be talking about the different bearings in the engine as I put on the update there. Was it the day before yesterday or yesterday? I can't remember. Now, this I don't think isn't going to be hugely exciting, this episode, because there's nothing that crazy inside a Formula 1 engine in terms of bearings, would you believe it? So I'm going to run through them all anyway, just to clear up anything that anyone is wondering about what's what inside the engine. So let's start with the crankshaft. Might as well start there at the bottom of the engine. So the crankshaft runs on just normal shells. Now I've got a pair of shells here I don't want to take out. I have got shells from various Formula 1 engines here, but they're still in the packets. I don't want to take them out because once you handle them, they're very easy to scratch, which I'll go through in a moment. So I'm just using two old shells here I found off the shelf. I'm not sure what they're off. They could be Mercedes. I don't know. So the principle is the same behind all shells. They're hydrodynamic bearings, which means that the shells go into the cutouts in the block. We'd say in terms of the main bearings, the shell would drop in to the bottom, one would go into the top. You'd put in the crankshaft, and they'd be clamped together then around the crankshaft, and the crank would spin between them. Now obviously there would be pressurized oil pumped in there, but it's not actually the oil pressure that creates the bearing film. It's actually due to a ramp effect of the shaft rolling on that film, that when it's rolling, it builds up like a wave at the sea. It builds up a wedge of oil behind it, so it kind of self-pressurizes. So now it still needs pumped oil, obviously, or it'll die very quickly. And that's how they work. I'm sure everyone watching hopefully knows about these bearings. They've been around for ages. Now in a Formula 1 engine, they're also the same on the conrod big ends. Same idea. They've even got the notch as well. Some high performance stuff doesn't have a notch here. They're like an anti-rotation notch, but any Formula 1 engine that I've seen, they do have the notches to stop them rotating. Now in passenger vehicles or in commercial vehicles, these shells are made a little different to compared to a Formula 1 engine, mainly because they have to run for many thousands and thousands of kilometers or miles. Now in this case with a Formula 1 engine, because the mileage is so small, they're generally kept thinner, because thinner means lighter, means less space, and means lighter. Now I think from what I was last told or read, commercial and passenger vehicles, the shells are made from, I think, 3 layers of material, where you'd have the outer steel layer. It would be then sputtered with a copper layer, and inside that again, I think there's a blend of zinc and some other material. I can't remember what it was. And then there's a light spray of a lighter, or a softer material, such as I'm going to say tin or lead, but they're all modern alloys. It's not those exact ones, but you get the idea. They're built up with layers. But in the newer Formula 1 engines, we'll say up to recent, or possibly even current, I'm pretty sure it's just the steel backing layer and just one layer on there. Now the inside layer is normally for, as you know, you can run steel on steel if you want to, but in terms of when everything is turned off, and if there is a foreign particle in there, if it makes its way in there, once the crankshaft or the big end would start rotating again, if there was a foreign object in there, it would scrape the inside of the steel bearing. Now I'm sure many of you have seen this with plain bearings where they get damaged by foreign materials. But the interlayers basically provide support for the shaft. Now these layers are extremely soft, which is why I don't want to show you a Formula 1 shell. Now actually, if probably be able to do it with my fingernail. If I just bring this up to the camera, you can see you can scrape it just with your fingernail like that. So it is quite soft. So that is why that is soft. I mean, it still provides support. You know, there's such a big surface area. It still provides support, but it can just absorb any foreign particles, and it'll hold on to them. They won't go spinning around forever with the bearing and damage the shaft. So that's kind of the principle behind those. They're basic enough. Nothing too exciting. Now, again, they'd be more exotic in a Formula One engine, but the principle and the basic materials are pretty much the same. Now, it did come up in one question: was the crankshaft running on needle roller bearings, or were the you know, on the main bearings? Now, I think it was done by Honda back the years, but it's done also in a lot of two-stroke engines. You've seen the crankshaft. I'm sure you've built some of them, where the crankshaft is built up. Um, you know, you put on your counterweight, you press in the shaft, put on the needle roller bearing, load up your conrod onto that, and continue on with the stack until you've your completed crankshaft, and then start dialing them all in to get them all, you know, evenly spaced, 90, 180, whatever, 270, depending on what it is. They're not really commonly used at all. I haven't seen them in any Formula One engine that I've had my hands on. Now, I know there's people going to say you can also get needle bearings with the half and half moon shapes like that, where you could machine a one-piece crank. Keep in mind, the stacked crank system turns out to be pretty heavy when it's all together, and you've got the high speed. You know, it's just not something you want in there as a multi-piece crank. Now, again, someone is going to say you could get a split bearing, a split needle bearing. You could do that, put it around it, but it's not generally done. Now, the main reason too with needle bearings in an engine like this with such big pistons, because the needle bearings are very much a point load. Like if you imagine, you know, if you had a shaft there like this with the needle bearings all around it, the surface area here is quite small. So you run the risk of, if you get an impact here from your combustion event, of putting a small divot there. You know, it's a very small contact patch. So that's another issue with needle roller bearings. Whereas on the plain bearings, you've got a huge surface area of support against your shaft. So I think that covers the crankshaft. Let's move on to the conrod, the connecting rod. As mentioned, same again in the big end, your shell bearings. In the small end, very similar to a road car, actually identical. You've got a silicon bronze or a phosphor bronze blend type bushing there. Now the Formula One conrods they're not rifle drilled. They rely on oil getting in here just from the high flow of spray oil that's coming up from the squirters, which we'll move on to in another episode of the full oil system. But nothing fancy there in the small end. So moving up from that, let's move on to the camshaft. The camshaft, as you've seen them before, I'm sure you've seen plenty online as well. They generally look like this. These are DLC coated, diamond-like coating. It just makes it very hard. It's like a vapor deposition process in a vacuum chamber. And again, these just run in the cylinder head itself, in the casting itself. There's no shells. It doesn't have these around it. It just runs in the casting with clearance, obviously with an oil drilling in, and runs on that wedge film that I told you about a moment ago. So that's how the camshaft runs. So no bearings there. And onto the valves. Let's cover every sliding surface or every moving surface. Again, you've seen this part before. It's just handy to display stuff with. Something I haven't shown you before actually is the valve guide from this assembly. Now, again, this is whatever material you want to pick. I can't remember the trade name of the modern valve guides. It begins with a C. I can't think the name of it, but it's just a patented blend of materials. Let's call it silicon bronze, aluminium bronze, whatever you want. Now, there's no obviously no oiling with these here. It's just a very durable material for sliding. and would be similar to the small end bushing material. So that's how they work. Now, one thing I forgot to show you on this is the valve stem, or the valve guide. I found one from the Brian Hart engine, just how it's cooled and how the seal works. So you can see two grooves here, which probably don't make a lot of sense, or didn't in the last video if you're hawk-eyed. This would sit like this in the cylinder head at an angle because it's a V10, and the oil would flow in here down the top. When this is shoved in here, then the oil flows in here into this little ring here, this little groove, and can then flow out. So that provides cooling to the valve stem. Keep in mind, you want to get all the heat out of the valve as quick as you can. So that's one way of doing it, you know. Now, in a normal engine, you would have the spring here, which would take a bit of the heat out of it. You'd have oil spraying on the spring. But because these are pneumatic valves, there is quite a thermal barrier here, where the heat can't travel out of the valve as easily because the valve isn't actually touching anything. This plunger again is not touching this. It's just touching it with the U seal on the piston. So there's no actual direct metal to metal transfer from the valve assembly to the coil spring assembly or to the oil. So that is why you need to suck as much heat out of it as you can. Now, obviously, a lot of heat does come out of the valve into the stem as well, but it does get a little bit of extra cooling of oil here, just with that groove when it's inserted. I'll bring it up to the camera and you can hopefully see how that works. It just flows in there around the groove and it can flow out again. So that's that bearing. Let's call it a bearing. It is a bearing, a linear bearing. So let's leave that aside, and we shall bring in, while we have it here, a finger follower. Again, this is off the Cosworth engine, similar on the CA engine as well. It's just a shaft that goes through the finger follower. There's no needle bearing there at all. It's steel on steel, and if you look very carefully, the oil can make its way in there. There's a tiny little flat on the side of that. You can just see it there. So that lets the oil in, collects here in the center. That oil is that, and again, where it's held axially, there's just two little grooves there which lets in and out the oil, and that's how they're lubricated, or that's the bearing that's used there. So that's another easy one. Again, I said it wasn't going to be exciting, this video, and it's not really, I don't think, but we shall trash on. So on the timing chest side of things on the Formula 1 engines, as you know, they've got a range of gears running up to the camshafts. Now, these are normally done with needle bearings, which I'm sure you've all seen before as well. If I just pull in the laptop, we'll have a glance at one of them, this one here. So again, just let me glance at that to see is there any glare. No, we're good to go. So this is a needle bearing out of the TJ engine. As I said before, let's just pick this one here. So the needle bearing is pressed in, and you can see there's a little hole here which the oil is running down the front of the engine. Just can go in that hole. It then travels in that hole there and oils the needles inside. Now, these needles run directly on the shaft. This is the water pump shaft, and you would have the gear there. So that the shaft is hardened where these run. There isn't a secondary race on the shaft. You can get a secondary inner race for these. If you're working with shafts that aren't hardened, you can actually buy the inner race and press it onto your non-hardened shaft, and that can run on it. But everything on a Formula 1 engine, because that would take up more space, it'd be more weight, all the shafts are hardened for the needle bearing surfaces. Now, again, if I just turn on the block up here, all the gears are done on needle bearings also. We'll just pick the bottom one. So this boss here, it would receive a top hat. Keep in mind this is aluminium, so you can't run a needle bearing on this. It would receive a top hat hardened bush. It would go in over that, and that would provide the surface for the needle bearing to run on. And this obviously is in the gear. So that's how they're done. Again, not too exciting and pretty standard. Now let's leave the laptop aside again. Now, of course, there is on the non oiled parts on the engine, such as the alternator. They do use bearings. Now they're normally by SKF. I know Ferrari uses exclusively SKF bearings in their engines for, I think, 70 years. That's just their supplier. But this is one bearing out of an F1 alternator. Now you can see it is a thin section bearing, but nothing special. Standard enough item, nothing crazy there. Now if we move on to something more fancy, you will have parts in an engine that are running in extreme conditions. Now on the Renault, I just close this laptop because the fan is going to come on. On the Renault, what was it? The Renault R25, or a lot of Formula 1 engines. The clutch, the engine is all, let's say here, the clutch is here and the gearbox is here. Now on some of the layouts, especially the R25, because I know it well, the clutch was hung off the end of the gearbox bulkhead. So if we just draw roughly, just that you get the idea, in plan view, the engine is here, the clutch then would be here, the clutch basket, and the gearbox then would go on here, and you'd have your first bulkhead here, and your second bulkhead and your shafts, and then back onto your differential like that, and your two drive shafts. But because this bearing, or this clutch assembly, is hanging off the front of the gearbox and in the bell housing, driven with the PTO shaft, which is the same on the TJ engine. You can see I think in one of the pictures in the last video, you can see the PTO shaft. It goes into the end of the crankshaft there and drives the clutch basket. Well, this bearing here on a lot of Formula 1 layouts, it's not receiving oil from the gearbox, because that's all the way in here, and it's not receiving oil from the engine because that's all the way in here. So this bearing here generally is just one bearing where it's running by itself, if you like, all alone, without an oil supply. And for that they pick what's called a ceramic hybrid bearing, which is a bearing with a standard type outer and inner shell, a pretty fancy cage, and even fancier balls. Now these are silicon nitride. Now they differ from steel in that they're ceramic for a start. They're very good at handling high heat or low oil conditions. Now of course this bearing would be filled with the very high temperature grease, so there is grease in there, but they can handle temperatures like in excess of whatever figure you want to put on it. They also, because they're ceramic, they're totally inert. They don't cold weld, even with, if there's contaminants in there. They won't cold weld to anything. They won't fret with the steel inner or outer races. There'll be no adhesive wearing, all of that sort of thing. They're extremely durable, and I think they were originally developed for possibly space. I won't say the moon mission, but certainly the space shuttle. I know for a fact they're in that, and they're pretty much made by one company, and it's called Cerobear. So I guess ceramic bearings, or ceramic roller bearings, would be what it's shortened to. But the other thing with these is they're approximately half the weight of a steel ball. They're beautiful. Like, if you take a glance at them, they're fairly precision. So they're ceramic, as mentioned, silicon nitride. Now they'd be fashioned first in a rough size, and they're then lapped with two diamond surfaces, which would run, to a specified tolerance from each other, and the ball would be put in between them, and it'd stay in there for ages until it was the correct dimensional size. Now obviously there's more to it than that, with controlling the rotation of the ball and how it orbits as it's been lapped, where it is in the position between the laps. But that's how they make them. Like, they're incredibly hard, you have to keep in mind, incredible. So you can get these in any type layout. That's what was in the R25 gearbox, which I would call pretty fancy, in terms of, you're not going to see this in your road car or anything. Probably a lot of you will never see these bearings unless you work in the trade, or you work with them, or you work in aerospace. They're possibly used as well in cryogenic applications, so you might see them there, but you will not buy these in your local shop. Um, so again, these cages, these bearings are all made. You can't buy these in a catalogue. They're all made to order. From memory, I think they're roughly about 350, 400 euro each, with a minimum order quantity of probably 20 or 30. So, you know, you want to be sure what you're ordering when you're designing one of these. Now, Cerebear do provide design advice. You provide, you know, your conditions. They will design the bearing for you, but they are expensive. Again, these cages. They will supply a silicon bronze cage, but they're a bit heavier. These are machined from Peak, from Virgin Peak. They're not injection molded. They're machined, again, custom machined, and they're very nicely done as well. Obviously, the purpose of these cages is to hold the balls in place at a specified diameter and position in the race. So that's how they work. Now, generally with ceramic hybrid bearings, or you can also get full ceramic, they generally don't run on a race that would be machined in house. So they will provide the inner and outer race. They don't really like handling your parts at their plant to grind the races on. They just prefer to supply you with the inner race, the outer race, and you press that on as you would with a normal bearing, just because they're so high tolerance. Now these steels, again, they would be the standard aero grade or aerospace grade steel, which is M50 generally. It's a very high caliber steel for that type of application. You can get various other grades to do as well, but that would be a fairly standard steel for this type of hybrid setup. But again, micro finished, you know, micro polished. You can probably see if it will focus, you can't really, but they're super high finish. You can get them in all sorts of layouts. This is just a cylindrical roller bearing again, just a different cage. You've all seen cylindrical roller bearings. It's just a different form of roller, like a needle roller bearing. They'll do those too. So this is the only, you know, this is as fancy as it gets in terms of bearings in an F1 engine, really, is a full ceramic or ceramic hybrid. One last thing to mention with these is because these are half the weight of steel, they can generally run a lot quicker as well in terms of RPM, because the balls, you know, with the rotational force, they're not trying to fly out through the bearing like a steel one would with G forces. So that is those. Just to cover this here for a sec, this is a part just to give you an idea of the heat inside the R25 gearbox. This is a part which lives in that section. Let's call it the bell housing section of the gearbox. Now this goes on the end of the selector barrel. I'm sure you've seen that, much the same as a motorbike selector barrels. Now I can't remember if the R25 had one or two selector barrels. In some of the gearboxes they used two selector barrels just to get rid of backlash, so you could time one off the other, you know, to just to be ready with the uptake quickly, so that there was no backlash play or no waiting for one gear. You could preload one against the other. But I think from memory the R25 had just one selector barrel. But getting back to these ceramic bearings, it just goes to show you the intensity of the heat in there. So as said, this was mounted on the end of the selector barrel, and it was a rotary encoder. I think it was a quadratic encoder, or it could have been just a potentiometer, I'm not sure. But it lived in there anyway. And because the heat was so extreme, like the clutch gets extremely hot, especially taken off, or if there's a small bit of slip, this sensor was actually cooled with this housing. So a nice little housing here. The sensor sits in there, and it's actually air cooled. So that's the type heat you have in there. You can see again the carbon from the clutch, the friction materials. I mean, it's not a nice environment in there. So you need the best bearings you can possibly afford or buy. Well, there's no problem affording bearings in Formula One, but the best bearings that exist. That's why that's so fancy. That's why it's needed in there. This again was a linear transducer, which recorded the position of the clutch slave cylinder. Now even this was cooled. You can see the cooling air would be ducted in here, in around this, and it would exit here then. So intense heat in there, and this bearing was all on its own some here, without being oiled. So that's why it's fancy. So I'm just coming up on 25 minutes, so I'm just going to pause the video and we keep going for another short bit, and that should be this one rounded up. Again, not that exciting, but just to show you what's going on inside the engine in terms of bearings. I'm going to do all this series right. We're going to cover everything, so let's get every one we can while we're doing it. So just one more thing before I put this part away, just as I was moving it off the bench, just to show you the lengths they go to thermally insulate parts. Obviously this is a coil inside here for the linear clutch displacement transducer, similar to what we saw in the piston type accumulator in one of the videos back. You'll see it's mounted in an O-ring there, and this is also mounted, this body is mounted in an O-ring too, just to isolate it from the thermals. You can just see the O-ring down the board there. It also protects it from vibration, obviously, gives them a bit of leeway in terms of stack up placement of where the shaft rides inside it. But those O-rings are mainly for thermal and just to isolate it away from the heat, because this is bolted to the clutch assembly. But yeah, a great lens. And something else I spotted, the K-type thermocouples, RS own brand. So you saw it here first, but that's that part. So I think that's kind of that episode. As I said, not very exciting, or maybe it is to some, but I think it's more of the mundane of the episodes. But it just covers everything. It's nice to cover, you know, try and get all the things, as I said, as we go. Obviously it's going to go up and down in terms of exciting parts or spectacular parts. You saw in the last update there, I've some cool things in the pipeline, and a DFE cylinder head. I've nearly the deal done on that, so that's just going to be immense. The V8, like it's a spectacular engine. Now I think that's going to be, you know, there's going to be a lot of work in that, in preparing it for camera, just deciding what to do. But I fairly know my way around cylinder heads at this point on how to section them without, you know, totally ruining the cylinder head. So I plan to section it up, see how they did it back then. I mean, it was probably the most famous V8 engine in the entire world, I'd say. Won the most races, was built or designed by a legend, built by a small team, as I said before, and a V8, you know. Now, it's a while off, but I think then to return in terms of recouping costs from it, because as you know, they don't fall out of the sky. I'll probably just sell off, polish the sandblast and polish the section bits, and sell them off in the link up there, in the buy me a coffee commissions section, just to get a few quid back on it. That's all. Not, I mean, just to break even, or even a bit less than that, I'd be happy. And plus, it'll also be still in the world. It won't be sitting here in a box, so other people will be able to show it off, or have a look at it, learn from it, and share the knowledge. But I think that is that. Just one more thing before I go on. As you know, V10s, V8s, they're the last of the greats. I think they're just spectacular. We're never going to see them again. They're engines, they're not power plants. The modern cars are power plants. They're engines coupled to batteries and regen systems and all that crazy nonsense. But I came across a video today on YouTube, and it's actually what this came out, as mentioned a moment ago, the R25, the Renault V10. But I'll put the link down below the video of a guy herding that car around the track. I think it was in 2020. But just immense. You know, he's literally, the car is just dancing around the track, and the sound of it, that's a proper car, as I said. And again, V10 engine, you know, the V10s and the V8s, you just cannot beat them. And they're like, the DFE was the start of all that in my eyes. Now I know there was other V8s before that, but just something else. So yeah, I think just to finish up, one more thing. There's a lot of questions of how did I get started, or how to get into this. Like, engines and engineering in my blood. I'd say I'm third generation. In fact, I found a very cool thing last week when I was cleaning up. Now, I wasn't going to show it on camera, but I'll show it because I don't really like talking about my history or covering you know, myself or my family, but it's just a cool thing. So as I said, third generation around cars. My grandfather had the first, or no, sorry, the fifth car in the town. So it'll give you an idea how long we're around engines. It was a Ford Model T, and I found something very cool the last day, which is this can. Now let me see. Can you see? I'll zoom in a minute. But this was taken from his garage after he moved in with my mother and father and my parents, and it's been in the house since. Now it was with him too for a long time, but some of you old timers will recognize it. It's the Gargoyle logo. It's the mobile oil would be written here, and it says here specially formulated for Ford Model T cars. So that's just beyond cool. And the reason I have it here is because this can is 100 years old last month. So it's been through a lot, as you can see. I think from looking online, and there's actually, would you believe it, a forum that deals with these cans. There's approximately, I think, 80 or 90 of these cans left in the entire world. So this is one with the formulated for Ford Model T. So that's you know, that's, I go back a long way, you know. So as the song goes, I was born this way. So it's in me. But let's just zoom in. So you can just make it out there. Especially recommended for Ford Model T. Especially recommended for Model T Ford cars. It's quite hard to see it, but it is there, better on that side. That's pretty cool. So yeah, I'm going to put in a picture actually now of about there was a gathering of Model Ts in town about 20 years ago. I think my grandfather stayed 25 years, but a guy knew him and he brought him for a spin in the car. And I put up that picture now, and you can have a look at it. But it's pretty cool. So I think that is that, without getting too bogged down in that. But that was that. Very cool. And that's one of his spanners, true fit. So still use them. Very cool. If they could talk, they'd have a lot of stories. So I think that's episode 12, and I should see in 13 where we will cover. What will we cover? I'm just looking at this here. We'll cover hoses, oil lines, coolant lines, different hoses, different methods of manufacture, and how many different types are on the engine. So let's do that, and I shall see you then. So have a look at the link down below of that 25 in running on the track. I'm going to put some more parts up probably tomorrow in the commission side of the Buy Me Coffee link, and have a look at that photo. Good luck.